In this video, I'm going to go through a couple of homework problems in My Open Math, and I'm going to use Stapplet to find the mean of a probability distribution, and then also for standard deviation, there's a problem to find that. So the first problem here is for a group of four 60-year-old men, the probability distribution for the number X who live through the next year is given in the table below. So I'm going to just type the values in there. So I have 0 down through 4 in the left column for the value. First, I want to show you what I'm using, actually, which one. So in Stapplets, if you look at data analysis, and then underneath that is probability, and then normal distributions and discrete random variables. So we want to choose discrete random variables, and then you add your data in, or just type it in. Can't really copy and paste with this one, unfortunately, and you have to click each row to get at it. I'm just adding, clicking this little plus to add the rows that I need. So it goes 0 down through 4 for the value, and then the probability has to be in decimal form from 0 to 1. So I need to get those typed in, and or you could just copy and paste each little individual. Do Control C and then pop over here, Control V. There's not really any other quicker way to do that. I'm going to pause the video and get those typed in. If anyone finds a quicker way to do that, please share. But as far as I know, you just type them in. But probability distributions are not generally very long for your homeworks. So this is a group of 60-year-old men, and the probability distribution for the number X who will live through the next year is given in the table below. So it is number of 60-year-old men who will live through the next year. And if you're just doing a homework problem, again, you don't really need to write all the titles in. Then I'm going to hit Begin Analysis. And we can see the graph distribution down here. I'm going to make this a little larger. And I had my decimals set like to go 5 places out, just so when I see my statistics, I can round accordingly. I think you can set it so that you don't have your graph showing that many. So you could play around with that, just going in here, adjust color, rounding, percent, proportion, preferences. From this data here, I get the mean as 3.26 and the standard deviation as 0.7766. And then again, I have my graph distribution. So I'm going to go ahead and put my mean in here, and I think we're fine with how we are rounding. It says report answer accurate to 1 decimal place. So we want to make sure we fix that answer. So instead of 3.26, we would want to put 3.3, and that's correct. The next one below is very similar. You're just going to take that data and put it into Stapplet. So I can hit reset everything, and then I just go ahead and type all the values in. So I'm going to just pause the video and get that typed in so I can show you. You could work along with me if you want. Okay, so I have that typed in. I'm just going to double check that I have them correct. And as tedious as it is to like, oh, I have to then click in the next box and type things in, it's still a lot quicker than if we had to do it out by hand, going 1 times 0.13, find the sum, and for each of those rows, and then add them all up, find the products across and the sum down. And for standard deviation, it's a lot more complex doing it by hand. So this is actually really nice. So I'm going to then hit B. I don't need this here. This is a generic problem, so I'm going to get rid of the variable name. I'm just going to say begin analysis, and you can look at the graph here, the distribution. See, we have a high point. I like this because if you hover, you can actually see the values, and it'll put it in percentage for you, which is nice. And then the mean down here and standard deviation is what we want to focus on. So does not say, I'm not seeing how it says to round here. So I'm going to try the one place again and see if that works. So mu is my mean. Let's see. Nope, they want it at 2 places. So we'll go 11.08. And then we have standard deviation is this lowercase sigma here. So we're going to put that in as I'll round to 5.89691. So I would need to round, if I go 2 places, it would be 5.90. We'll see how it likes that. It just gives the whole number, but it should be fine. The sigma squared here is the variance. So we need to just take that, do that out by hand. So I'm going to go 5.89691 and then square it on my calculator. And I get 34.77. Okay. And the expected value of X is the average, on average, what I'm getting for the probability. So, or for the value. And that would be the same as like a weighted mean, or just this mu here. So that's going to be the same answer, 11.08. Okay, and then I'll submit and see how it likes the rounding. Yeah, that was good with that. I'm also going to show you how to set up question 10 in your homework. Well, the numbers could vary, the problem can vary. They're algorithmically generated, but this is one where you're finding expected value of a raffle. The PTO is selling raffle tickets to raise money for classroom supplies. A raffle ticket costs $2. There is one winning ticket out of the 210 tickets sold. The winner gets a prize worth $62. Round your answers to the nearest cent. What is the expected value to you of one raffle ticket? So using Stapplets, I want to put in the value. I put in my loss first. You could do it vice versa, that's fine. But I put in -2 if I lose. So I took the losing tickets would be 209 losing tickets out of 210. And I just divided that, and I got a long decimal, and I put in as many digits. You know, I put in 6 after the decimal just to avoid rounding as much as possible. So I have 0.995238. It will not take it as a fraction. So a lot of times we like to keep things in fractions so that it's not rounded, but these programs, you have to do it out as a decimal. I believe GeoGebra might have the same caveat as well. And then I looked at $60 for the other value in the left-hand column, second row, because the winner gets 62, but they've paid $2 out. So we have to subtract that off, and then I just did 1 divided by the 210 and got 0.004761. So when I hit that, so my numbers in the right-hand column, just to repeat, are 0.995238 in the first row. And the second row of my probability distribution for probability is 0.004761. And then I click Begin Analysis. And I've already done that here. And go down to the summary statistics, and I get the mean and the standard deviation. I'm not asked for standard deviation in this problem, just the mean, and they want it as rounded to the nearest cent. So I'm going to put in negative. So make sure you have that negative. So that's a loss on average of $1.70 per game. And that's what expected value is. So when you're doing these, a tip is make sure that you have taken off what the cost to play the game is, as well as put your probability in decimal form. And if you go out like 6 places, you shouldn't get much rounding error. I hope that helps. Have a great day.